Lesson 41, the quantum model. And if you've already watched lesson 40, then the secret has been given away already. I couldn't resist. The quantum model answers the question of why do electrons only exist at certain energy levels? And the answer in our present model of thinking is that electrons, we should not consider electrons as particles. We should consider them as standing waves. And if an electron represents a standing wave around the nucleus, then it can only exist at specific wavelengths that allow constructive interference. So here's the explanation of that. If I have a certain rate, I have this radius right here. Oopsie. At this radius here, given this wavelength, I get complete constructive interference here, and therefore the electron can exist at that specific radius. If the radius is made smaller, as in this case here, what happens is I don't get, when I come around here again, I don't get constructive interference. I get destructive interference, and therefore the electron cannot exist at that radius right there. So that's why the electron can only exist at specific radii. They must be multiples of a certain wavelength. All right, and that's really it. It also explains why electrons do not emit EMR spiral into the nucleus. If the electron exists as a standing wave, not as a regular particle, since it's not an accelerating charged particle, then Maxwell's theory of EMR does not apply. And then it says, remember that Bohr's model could explain orbits in atoms, could not explain anything except for hydrogen. The new quantum model can. And this is great. Just read this. For example, if you add another proton to hydrogen, you get helium. So now you've got two protons, and therefore those protons are going to have a different electrostatic force between them and the electrons. The extra positive charge exerts a greater force than the electron and draws it into a smaller radius orbit. The electron's velocity adjusts. Now it has a different wavelength. This means that the radius must be different. So this is brilliant because it just ties many things in together in a very neat little package. If you follow this theory, the electron stops being a particle orbiting the nucleus at a certain point. Instead, the electron's mass and charge can be thought of as spread out as a standing wave around the nucleus. The electron is not really at any one position as a particle. It is everywhere as a wave. All right, that should blow your mind. The electron is not a particle, it is actually a wave. And if you remember, if you watch the Dr. Quantum video, in the Dr. Quantum video, they took electrons, right? They took electrons and shot them through a double slit. And what did they see on the screen? They saw an interference pattern, which is totally mind-boggling. I mean, you can understand if you put a wave through a double slit, you get an interference pattern. But if you put a particle, an electron, you get an interference pattern. Well, now that makes sense why you get an interference pattern, because the electron acts as a standing wave. And so it can go through both slits and interfere with itself, or it can go through one slit or just one or just the other or neither. Anyway, watch the Dr. Quantum video again. And again, this should tie everything in together. And then the last thing we'll do is look at the PhET demo very quickly. Here, let's go back to the Bohr model. So here's the Bohr model with the electron as a particle. Works pretty nicely. But here is the de Broglie. Here's the quantum model. Now the electron, look at it. It's a standing wave. Standing wave, and it's getting hit by white light, so it's getting hit by all these different frequencies and wavelengths of light, which are moving this electron from one level to another. If it goes from an outer level to an inner level, it emits EMR. If you, can I slow this down? Slow. Let's slow it down. Here we go. So it's in the level 1 here. It got moved into level 2. Sorry, it got moved when it gets moved into a high level. That photon is absorbed. So let's see if we can see that. Let's see if this one's going to hit it, move it to high level. No, maybe this one. No. Oh, yes. The one behind it. There was one behind it, and it got absorbed. Whereas when it goes from a high level to a low level, it emits EMR. All right, that's the quantum model. Oh, wait, let's go back to the lesson. And then it talks about an electron cloud, and that's the Schrodinger model right here. There's your electron cloud, which is definitely more university level physics. There it is. And that's where we stand with the present model of the atom. Farewell. We'll see you for the nucleus. That's coming up next.